This is the art of network engineering, where technology meets the human side of IT. Whether you're scaling networks, solving problems, or shaping your career, we've got the insights, stories, and tips to keep you ahead in the ever-evolving world of networking. Welcome to the Art of Network Engineering podcast. My name is Andy Lapteff, and in this episode, I am joined by luminaries, kings of their field, if you will. We're going to start with Mr. Michael Bushong. Hi, Mike.
Mike, you're missing your crown. I'm looking.
No, I'm sitting on it.
The wheels have already fallen off. Hi, Mike. Have you said hi yet?
Hey, Andy. Thrilled to be here.
Thank you for stepping in. We had somebody dip out, and Mike jumped in, so thank you. Russ White, sir, how are you? It's great to see you.
I'm a year older.
Russ, I looked up the last time you were on the show, and it was almost 3 years ago. It'll be 3 years in January. So that's been way too long. And I re-listened to the episode, and I learned more stuff. So you're one of those people that I learn something from every time I talk to them.
Anytime you want me on, you know how to find me. I'm always around doing something.
Listen, pal, I'm still waiting for my hedge invite, buddy. Podcast wars.
That's doable too. That's fine.
No,
I've been trying to get Mike on the hedge. It's always a pain to get him. He's traveling so much. It's hard to get him scheduled.
I love your show. I love listening to you communicate about networking. It's really, it's always a fantastic time. So this episode is going to be me kind of picking a fight with you about ISIS. And I say that lovingly. Kevin Myers, a friend of ours, we did a BGP episode and it blew up and people were in love with it. And I thought, wow, people really want to talk for an hour about a protocol. That's interesting to me. So, but it was a good conversation and we were beating up on BGP. I think he quoted you as having said BGP is the trash can of the internet or trash can of data center, whatever it was, right?
The
Is that the quote?
Yes, it is.
The internet. Right. We just throw BGP on everything. And so somehow in that conversation during the BGP episode, ISIS came up. And I'll be honest with you, in all my years I have certifications from multiple vendors. I've managed the things and studied the things, and I've never come across ISIS. So I think the framing here would be, wow. Yeah, I know. So the framing here is, it's a design discussion, I think. And really, why do we need ISIS, right? I've never used it, and I've managed Fortune 50 global data centers. So it must not be, right? I'm being provocative, right? Like, we don't need this thing. Change my mind. But I'd like to talk about routing protocols. Like Mike and I were talking earlier, and we were thinking about some different scenarios, like, or analogies, like we don't think about what the pipes in our house are made of, right? Like, I really don't care. I just want the water to run. And really, if we think about networking infrastructure, it's just plumbing, right? Highways are another analogy, but I don't know if I care what the pipes are made of. I don't know if I care what routing protocol you're running. They all kind of do the same thing. I mean, I've run RIP, EIGRP, OSPF, BGP, right? EVP, VXLAN. To me, they all kind of do the same thing. Now, I'm provoking you because I know you're Mr. Design and you're going to tear me apart, but
no, it's okay.
I don't know where we want to start. Do we want to start with why would you pick one routing protocol over another? Like, who cares which one you use? But I really want to jump into ISIS because I know nothing about it.
Okay, so I'll begin here. First of all, BGP, Tony Lee got really mad at me one time when I said this because I said it in his hearing. BGP to me is less of a pure routing protocol and more of a policy distribution system that happens to do loop-free paths sometimes. I mean, 99% of the time, it does loop-free. I don't know if 99% is the correct amount of time, but BGP is slow, extremely policy rich. If you ever throw, 120,000 routes at BGP in a dense topology and try to pull the routes out, you will find that either it will not converge ever, or you will find, unless you do the correct design work, or you will find that it converges very slowly, like minutes.
But that's by design, correct? Because we don't want flaps on the internet to change all the things every minute.
Well, it's because it's not a distance vector, it's a path vector protocol. And it's just, as radio would say, it's routing by rumor. Like, it takes a long time. And because of the way it works and because it depends on TCP and it has a lot of overhead in dealing with all those 13 or whatever they are steps now. We keep adding to the steps in the best path process.
You say relies on TCP like that's a bad thing.
Well, it means it's a bit slower because you're actually one step up, right? It's more, well, I won't even say that it's more reliable because it's really not more reliable than flooding in either OSPF or EIGRP or ISIS. But it is more multi-hop reliable. Like ISIS doesn't do multi-hop. And you would really struggle to do multi-hop with ISIS.
How did it get in the data center? Because it was supposed to be for the internet. It wasn't supposed to be an IGP. Right?
Because Peter Lupkoff said, I need something that'll scale to 120,000, 200,000 routes, and I need something that'll do traffic engineering. And at the time he came up with these requirements, number one, nobody believed that ISIS or OSPF could do 120,000 or 200,000 routes. There's always been this thing that these IGPs can't scale. Now that you can't do 1.2 million routes, but you can do 120,000 routes in ISIS or OSPF.
Following so at that point though, a bunch of people standardized on.
Yes.
So, it's been proven that it works. And so the question is, if the network works, if the data center works, if it scales, if it ain't broke, does anybody care at this point? I know that you care, but does the average network architect?
I think Mike's asking me why I care.
Because I've asked you before, because to me it's not just ISIS, right? There's the whole Rift discussion. There's and the commercial challenge with all of that stuff for people who build product is that the set of people who care are infinitesimally small compared to the number of people who don't, which raises a question if the average or even let's say above average person doesn't see much difference or enough difference to go and upend their architecture, should we spend time on it at all?
So a couple of things. The first is that most of the time when I sit down and spend time with people who are doing large scale fabrics or mid scale fabrics, if I explain to them my reasoning, most of them will go, oh, I agree. We probably should run an IGP separate from BGP. But then the second answer you'll get immediately is, but nobody in my NOC knows how to do anything but BGP. So therefore, no matter how good I think much better the design I might be, I don't really care because my NOC can't support it. They can't support anything but BGP. Now, I have honestly very little sympathy for that answer, but that's me.
Hold on.
Is there anything more complex than BGP with everything, when it's doing everything that it does?
So I have two problems with using BGP for all of it. The first is we are twisting. This is why I say BGP is the garbage can of the internet. We are totally, BGP was designed so that you had to manually configure neighbors. Because I'm talking to a customer, I'm talking to another network that I don't know anything about. And it's very policy driven. So I want to be very intentional. Even the way that BGP is set up by default, which wasn't always this way, by the way, which is why there's a lot of implementations that don't do this. But the way the RFC changed it so that you have to have policy configured to advertise something. Everything is meant to be intentional. It's meant to be slow. There you go, Andy. It's not supposed to converge fast. It's supposed to converge slow. Supposed to be very intentional. And then we throw it in a data center and we go, oh, but it needs to converge faster. So you know what we're going to do?
BFD.
We're going to change everything about the way it works. We're going to configure it so it looks like fancy RIP. That's literally what we do. We're going to make it so the neighbors come up and you don't need to manually configure any peering sessions. Now, at some point, you're like, this is a completely different protocol. Why am I building a completely new protocol on the same packet formats just because I can call it BGP?
Is it because the people are familiar with it? Like to Mike's point earlier, who cares? And you said the NOC knows BGP. I came up at a NOC, and if you told us who all knew BGP, now we all have to learn ISIS and make it reliable. That's a lift, right? For people who are working 32 tickets a shift.
Yeah, it is. The beauty of splitting it, of having an IGP and an EGP, is exactly the way we used to design transit networks, is that I separate my infrastructure from my workload. And today in the data center using BGP, my infrastructure and my workload are blended together in a single table. And people play games. Oh, I can make the infrastructure eBGP and the workload IBGP, or the other way around. Various people do different things with this. But to me, having them in separate protocols makes a lot more sense.
Quick question. Is that to constrain failure domains? Like you said earlier?
Yeah.
Yeah.
Yep. Exactly. Okay. That's why. That's one reason. Another, not just failure domains, but it's also security domains. It's also my attack surface is completely different. And one of the reasons I like ISIS in this role is because ISIS is not IP based. So you cannot send multi-hop ISIS packets.
Let's take your segue, because when I looked up ISS earlier in my new teacher, ChatGPT, the first thing I saw that exploded my brain was it's a layer 2 protocol. And I refuse to understand or like the fact, not that anybody cares what I like, how the hell is a layer 3 routing protocol operating at layer 2? Please explain. And why.
So originally, the thinking was exactly the opposite. One of the big concerns about using Dane, which you probably don't know what Dane is, but essentially when RPKI came out, one of the things I was working on when I was at VeriSign was, why are we building a separate database? We have this database called DNS. It's already distributed. It's fast enough. I can add a new DNS record just like I have a CA or a CERT or an HTTP or whatever. And I can just add a new one that is the 501 certificate for origin authentication and stick it right in DNS. So now the router can query DNS and it's going to get a cached response back with the correct origin stuff, and it's just going to work. And people were like, no, you can't do that because you can't have routing depend on DNS and DNS depends on routing.
It took 13 minutes for me to get lost. So I did pretty well. That's good for me, following Russ. So what does this have to do with building it on layer 2? We went to RPKI and DNS and Crazy Town.
Okay, so when ISIS was invented by Radia and Mike Shand and
Radia
Stewart
helped invent this.
Yeah,
It's
Radia
her
was
fault.
on the team. Yeah, with Mike Shand.
I should have known. The person responsible for spanning tree would invent something as terrible as ISIS.
Oh, well, it's
I
really
love her. I'm teasing. We're going to have her on soon.
It's even funnier than that because she invented routing before she worked on routing. I shouldn't say she invented. She worked on routing before she did spanning tree.
Yeah.
Spanning tree she didn't want to do it. Like she does not like spanning tree.
I know. She doesn't like Ethernet. She doesn't like spanning tree. It's my favorite part about her. The thing she invented, she calls garbage, which I really think is funny.
She likes Ethernet, but she's still like part of the reason she did Trill. She and I did Trill many years ago, tried to do Trill, was to get back to the original concept of routing, even at layer 2. Don't do this spanning tree stuff. And she's not ever been a huge fan of that.
So you were there. Let's leverage that. Why was the decision to create another internal gateway protocol made? I guess OSPF wasn't doing something they needed it to do?
Nope. It's the other way around. So ISIS was designed first, even really before spanning tree to some degree. And the reason it was layer 2 was because, again, they thought, first of all, ISIS is not an IP protocol, right? It was designed for CLNP and CLNS. It was not designed for IP.
I don't even know what that stuff is. That was just before IP, right? It was transport stuff before IP.
Well, no, it's parallel. It's parallel.
Yeah.
It's at the same time. OSI stuff, all these ISO protocols. At that time, by the way, there was Banyan Vines, which was a layer 2 protocol that ran on top of something called VIP, which was its own version of IP. And there was Novell Network, NetWare, which ran on top of something called IPX, which was an analog to IP, but it was essentially a layer 2. And so the thinking was you don't want a layer 3 protocol dependent on layer 3. You want a layer 3 protocol. If you're going to carry layer 3 connectivity, it needs to be in a layer 2 protocol. And so that's part of the reason.
That wasn't the first IGP, right? Like, again, why did they create ISIS? What was it for?
So the first IGP was what was called the Hello protocols, very similar to RIP, but without the hop count limit, and it crashed. It crashed bad. So they had a flag day and they replaced it with a link state protocol, not ISIS, but a link state protocol. And that developed eventually into the OSI, the ISO protocols and everything else that resulted in IS-to-IS.
So then why did OSPF win?
So first of all, I don't know that OSPF is one, but that's another.
Everybody knows it. You and Roddy are the only 2 people and 3 other people at hyperscalers that know ISIS. Right?
Yeah, well, I don't know. I mean, most of the large-scale networks that I've ever touched, other than perhaps AT&T. I think AT&T is probably the lone standout on OSPF. But Sprint has always been.
But the question's the same. So ISIS kind of, so you create this separation, right? Separation of concerns, and then that gives you some measure of resiliency. Right? So that's a positive.
Mm-hmm.
Presumably, you'll at some point, it probably didn't matter at the beginning, but you'll get different scaling characteristics as a result of that. So, okay. But then OSPF comes along. So why create OSPF if ISIS is the answer? And just so you know where the story arc is going, if you create OSPF because ISIS isn't getting there, and then you use BGP because OSPF wasn't getting there, how do you end up back at ISIS?
This episode of The Art of Network Engineering is sponsored by Meter. Meter delivers network infrastructure for the enterprise because every organization deserves seamless connectivity. Whether you have a large team of network engineers or an IT team of one, Meter makes it simple to get online and stay online. Meter provides a full-stack integrated platform that combines hardware, software, deployment, and support, so enterprises can ensure their networks have the performance, security, and reliability they need without the inefficiencies of juggling multiple vendors. It's enterprise networking reimagined, giving IT teams the ability to spend less time managing complexity and more time driving business strategy. Go to meter.com/A1 to book a demo now. That's meter.com/AONE. Now back to the show.
Okay. So OSPF was created because way back in the day, most processors were little 8-bit processors, and they didn't like TLVs at all.
Can you tell me what a TLV is, please?
Yeah, a type length vector or a type length value, depending on like how you want to. So essentially on the wire, I can tell you what I'm going to tell you as part of the packet. I can inline, if you think about it as a grammar or dictionary, I can inline the dictionary or the grammar. I can say, I'm going to tell you this word and I'm going to give you the context of how I want you to understand this word in line.
Is it a header bit that notifies you what's coming?
Yes.
Frame? Yeah.
Correct. It's a header that tells you, right. Right. So think of Spanish or Greek. Greek in particular is a big one for this, more so. And the conjugations in those languages, right? Like in Greek, if it's a female or a male verb. Why would you ever care about such a thing? Because you want to know what word in the sentence the verb applies to, or the adjective or the adverb applies to. And you do that with gender differentiation and other ways of doing it. You don't do it by word order. In English, we do everything in word order. Where's my subject? It's before my verb. Where's my object? It's after my verb. Greek doesn't work that way. Hebrew doesn't work that way. A lot of languages don't work that way. You actually tell what the object is by the ending on the word tells you this is the subject. Could be the last sentence, the last word in the sentence. Could be the first. Doesn't matter where the position is. So this is the way a TLV works. I don't care where it's positioned in the packet. I'm telling you by conjugating it effectively, by telling you this is your metric. Your metric is going to be 6 bits wide. And it doesn't matter where I put the metric in the packet because everyone knows TLV number 1, whatever it is, 133, 132, that's going to be the metric. So this is great from a flexibility perspective. And this we'll get into, right? Maybe perhaps we'll have time to talk about OSPF versus IS to IS and their flexibility as protocols. But the guys who designed OSPF had 2 goals. Number 1 was strip the TLVs because they're bits on the wire. I don't want the bits on the wire. I want the protocol. I mean, look, when I was in the Air Force, we did an entire white paper taking a sniffer and measuring the efficiency of sending an X megabyte file, 10, 20 megabytes, because at that time we weren't doing gig files, over Vines versus IPX with NetWare versus IP versus OSI. We actually did a white paper where we measured which one put more data on the wire because we were running 1 and 2 and 3 meg per second networks, and we were running inverse multiplexers on T1s. And
so chatty protocols weren't great.
Yeah. Exactly. What is
Back when you're
chatty?
running a fractional T1 at 64K and that mattered, where now we're running multi-gig and who cares, right?
So at the time, ISIS was considered a much chattier protocol. We want to make a less chatty protocol. So that was one reason.
For bandwidth constraints, and also, like you said, the CPUs that were in use couldn't handle all the
That's correct.
clocking.
Yeah.
So is your argument that's all marginal now? And so then the constraints...
It's well away marginal at this point. And what's happened over time is, if I want to support IPv6 in OSPF, I have to build a totally new protocol. The whole protocol is built around the v4 address space. All of my fields and all of my packets are fixed length and set to 32 octets or whatever.
So BGP could add an address family, and ISIS you could do a TLV, but OSPF you have to refactor the whole thing.
Exactly. So what's happened in the long run is OSPF become a very complex protocol. I mean, you have however many different types, packet types and everything else, and now they've added TLVs to it. Whereas ISIS, I mean, the biggest complexity with ISIS as far as packet format goes is, we messed up and put in 6 octet or 6-bit metrics. Oh, we need bigger metrics than that. Okay, so we'll create a new TLV set to do these new metrics.
So I'm a network operator and I want to add a new TLV type, let's say to support V6 or something cool that's new, Rocky V2, whatever it is. Is that an upgrade of the code? How do you upgrade a TLV? Does it come with the next version, or is it a command?
It's a new version of the code. I mean, you would have to
you'd have to upgrade.
You'd have to create a new TLV type, get it standardized, or run as an experimental or an opaque or whatever you want to do.
But who drives that? Like, is that IETF? Like, where would the new TLV? Yeah, okay, they get together. They say
that's in the LSR working group. Correct.
If the protocols, so let's say they evolve to overcome limitations and kind of the load that those limitations bring, and then you end up removing the limitations. If you've already moved on to whatever the new protocol is there still justification to then make another change? And let me give you kind of a weird example. Cloud comes out, every board in the world gives their CEO a cloud directive. You must go to cloud. How are you getting to cloud? Companies all over the world perform the great lift and shift. They spend a bunch of money. They refactor their applications or rewrite them entirely. Now their app, instead of running on-prem, runs in the cloud. There's no difference in what the app does. Maybe it's marginally less expensive in the short term, and then cloud proves out to be not quite the economic benefit that everybody thought it would have. Do they move their apps back? Like, they don't. They just leave them where they are because you're like, I've already incurred the cost once. The benefit is marginal. I'm not going to go back.
Yeah, I guess it would depend on how marginal the benefit is, right?
So do you think that the benefits are large enough? I mean, like, because you are like an ISIS zealot, right? I mean, like you are...
I wouldn't say I'm... Yeah, okay, go ahead.
Well, you okay, maybe not a zealot, right? You're like...
No, he's a zealot.
No, but I mean, like, you write on your sneakers, I heart ISIS, and you put in, like, you were practicing, like, your last name, like, I'm going to be Mr. Russ ISIS. Like, you have a love affair with ISIS. So do you think that the benefit is there? And then I'm going to set you up, like, this is a trap. So just be aware, you're about to step into a trap. Because I got a follow-up question that once you answer this one,
that's fine. So ISIS was almost dead. Honestly, almost no one was using it. It was very, very, very few people, but several things happened generally around the age of the explosion of the dot-com bubble and the growth of transit network. Sprint and SprintLink being particular, Peter Lothberg and his work being particular things that happened. First of all, the original implementation of OSPF in Cisco iOS, old classic Cisco iOS, was marginal. It was okay. It was fine. I don't want to put anybody down or anything, but it was not the most optimal implementation as far as shortest path first, flooding, all the components of it, they were there. There was literally a thing on the Cisco Online website that Don Slice and I had to go and spend 6 months proving was incorrect to get it taken off the Cisco Online website, which was you should never have an OSPF flooding domain or an area larger than 40 routers. We had so many problems in TAC and global escalation with flooding domains larger than 40 routers. In our OSPF implementation, they literally put it in the documentation. No flooding domains over 40 routers. No areas. Like everything beyond that's going to be distributed, blah, 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 all this other stuff.
Is that a scale constraint of OSPF? Just full stop?
It's a scale constraint of that particular implementation on that particular hardware.
Right.
It's not the protocol itself, right? So I'm being very careful here.
The distinction between implementation and the reason they had to remove it was because they took an implementation detail because they had so much weight in the industry in terms of what was accepted and not. A post designed to reduce TAC calls turns into a pseudo standard.
That's exactly what happened. That's right. And so during this time, Sprint and all these other large providers, these transit providers, they were throwing 1,000, 2,000 routers, 5,000 routers in their networks. Okay, you design an OSPF network with 1,000 routers with a 40 router limit in your flooding domain. Okay, good luck with that, because that ain't going to happen. You just hit practical reality. So they just tried ISIS. Well, it just happens to have turned out that Tony Lee wrote the original ISIS implementation. And there were some very good coders working on it, Hank Schmidt and some other people. So the ISIS implementation was beyond excellent. It was such a good implementation.
Does the ISIS documentation lead with that? Like, this is better for scale?
No, nope, not at all.
Was that an accident? Tony such and such? Like, how did they know to do that? They just tried it?
They just tried it.
Let me jump in with a question. So do you like ISIS because it's a better protocol, or do you like it because it was implemented better?
I like it because I think it's a simpler protocol.
Mm-hmm. Simpler. Okay, so simpler is doing a lot of work for you there.
Yes.
Unpack simpler.
It's rare networking, right?
Yeah. So hang on. So basically I figured out we can do 5,000 to 6,000 nodes in a single ISIS flooding domain. A single ISIS flood. Like, you don't even need flooding domains in ISIS necessarily. It depends on your route count and your processors. And
that's like an area, right? Is that?
Yeah, it's an area. It's the same thing.
Can you connect routing? Can you connect ISIS areas? Yeah.
Yeah. It's exactly like OSPF. You have an ABR, blah, blah, blah. There are some critical differences, by the way, that, again, I prefer ISIS's implementation for. So ISIS is a simpler protocol in that I have TLVs. I don't have all these types. I'm not going, oh, it's a type 5 and it hits an ABR and the type 5 generates an E-bit and in a type 4 with a type whatever it is with this and that. So
the route types and the LSP and LSPF created
I don't have any of that stuff, right?
But aren't TLVs just a different route type?
No.
Isn't it the same thing?
No. Everything is also backwards in ISIS from OSPF in some ways. So, for instance, in OSPF, when I hit an ABR, my default is I create a type 2, which is essentially says everything that I get in my type 1, 2, it's not type 2, it's type 3. This is why it gets like, it's a summary LSA. So I create the summary LSA and I say everything that's a network LSA or a link LSA or a router LSA gets summarized. And the way it gets summarized is I take the metric and I attach them to the type 3, the summary, as if all those things were connected to me, right? That's what I do.
Which seems like a good idea because you're summarizing routes, which reduces the routing table, right? Like, I mean, this is all good.
Right.
Yeah.
And so I do it in both directions. Area 0 into my outlying area into area 0. And if I want to only have a quad 0 in my outlying area, I've got to configure all that. I got to make it a totally stubby. I got to think through, am I going to redistribute? Does it need to be a not so totally stubby? Does it need to be a totally stubby? Does it need, there's all these different things I got to think about. In ISIS, you put the same intermediate system in both flooding domains with net statements, and it's automatically a totally stubby area. In fact, it's a totally not so stubby area. It only sends a default from the level 2 domain into the level 1 domain. And then you summarize just like you do in OSPF from the level 1 domain into the level. So your outlying area into your area 0. So everything is backwards. I have to intentionally leak the routes.
It's embedded in the logic of the protocol instead of having to turn all the nerd down like OSPF.
I just do it and boom, I'm in a totally not so stubby area. Like the most complex thing I can configure in OSPF is the default in ISI.
So the configuration is simpler. It's less complex.
It's not even just simpler. The protocol itself is simpler in that way to me.
Right. It's
going to do more like on its own. So then, Russ, if somebody was like, if you had your way, right? You teach classes, you build out curriculum, you educate people on how to do architecture. You're very committed to having people understand the why, because the recipe model of building networks leads to misunderstanding and complete architectural abdication. And then you end up with things where Amazon West goes down.
Yep.
And an entire company is unreachable because they basically said, we don't own the architecture. That's Amazon.
Yep.
If you were building, like, let's say you were educating the world today. So let's say that magically we make networking cool again, and
Alexis wins.
and then there's 50,000 network engineers that enter the workplace over the next couple of years, and you're going to be training them all. What do you tell them? Like, what protocol? You're like, this is the architecture you should go with. What do you tell them?
I would always do an ISIS underlay with a BGP overlay, personally. And I'm not going to say that you shouldn't ever use OSPF. That's okay if you want to use it. It's just not my preferred way of going about it. It's like using BGP alone for all of your data center fabric. You can do it. I know how to design it. I've done it many times. Is it my ideal? No, it's not really my ideal because I know where the holes are.
But it's your position that if people were starting from scratch, learning everything from scratch, they would find ISIS simpler to deploy, and then sort of almost, by definition, simpler to learn.
Yes. So when I used to teach OSPF in Cisco TAC, and then I would teach ISIS because they insisted I do OSPF first.
Okay. So here's your trap then. You ready for the trap?
Uh-oh.
No,
okay.
so hang on.
This is the trap, Russ.
It's coming.
I warned you ahead of time that I was walking you into a trap.
So I would always teach OSPF first. And then when we got to the end of it, people would say, aren't you going to teach us ISIS? And I would say, just forget half of everything you know about OSPF and you already know ISIS.
Who are these weirdos who ask for ISIS?
Well, okay.
That was always my answer.
Russ, you're on the witness stand, and so you are obligated by podcast law to speak the truth, the whole truth, and nothing but the truth. If you are indeed in a long-term relationship with ISIS, do you have what's going on with your side piece Rift?
Okay, so I used to say this all the time. RIP is not a routing protocol. It is what you put on your gravestone.
No, Rift, not Rift.
Oh, Rift. Oh, I thought you said RIP.
No.
Yeah. And actually, RIP's a perfectly fine protocol in very small networks, but I'd never deploy it at scale. But Rift. Okay. So Rift is interesting. I like Tony P a lot. And I'm actually on the Rift drafts, I suppose, still. I don't know. Maybe my name is still there. I've looked at
Humble brag.
Huh?
Humble brag.
I say this
You're
just
on
to
all of them. Stop it.
Yeah. I just say this to say that I don't hate Rift. It's not like I'm down on Rift. I helped design.
I'm looking it up in real time. I have no idea what it is. Routing in fat trees.
But if ISIS was objectively better and simpler, why look outside the marriage?
So Rift is essentially an attempt to make it where you can fire and forget in extremely large scale. Because Tony P and I have a bit of maybe a small disagreement over the scale to which you can push IS to IS with modifications. Because if you go look up disk-top flood, which Mike, you know all about disk-top flood, I think you can push IS to 5,000 routers with disk-top flood in a dense environment and have a lot of routes in it, and it's fine. So the biggest problem with doing that is that your top of rack switches, which are your cheap switches most of the time in most designs, you have very cheap boxes up there, have very small forwarding table sizes. So if I have to throw 120,000 routes at this thing or 200,000 routes at this thing, those poor edge switches are going to run out of gas really fast. And not only that, they share their table size with their filtering tables. So Tony's perspective is that in order to save that memory and make those small boxes viable in a large fabric, you build a protocol that sends nothing but a default down from the spine towards the top of rack. So you reduce the table size. So he basically took IS to IS. He took disk flood plus IS to IS. And then he said, well, you know what? Is there a way for me to only send a default to each one of the top of racks? And so he figured out that he could do basically a distance vector from the spine to the leaf and a link state from the leaf to the spine and make an incredibly scalable fire and forget routing protocol. And it gives you all sorts of interesting things like it does. So Distop-Flood originally, many years ago, had the ability to calculate which stage I'm in. I could actually figure out from the router's perspective, I could say, oh, I am a top of rack. Oh, I am in the spine. Oh, I am in the fabric. I am up at the plane layer. I could actually figure that out. It's not actually that easy. It's mathematically impossible, as Ivan Pepignac read my draft and he went, what you're doing doesn't work. And I'm like, uh-oh, that's a problem. So I spent some time with Ivan figuring out how to make it work. Thank
Russ,
you.
this is all Rift, correct?
No. This was before Rift. This was just Flood.
So that's where I was getting at. You've mentioned that a few times. I don't know what Distop-Flood is. Is that
It's a flooding optimization draft for IS to IS and OSPF.
Distop? Is that what you're saying?
Distributed optimum flooding.
Thank you.
Yeah. And so he took all of that work and he added it to his distance vector plus link state and came up with Rift. Rift has a lot of really cool properties. My concern with Rift, I suppose, is I'm not really sure we need it all the time. Like, I'm much more of a just use what's already there. Why am I, like you said, Mike, right? Like, it's there. Everybody's implemented IS.
Well, it's there for scale, I think, right? Once you get over that 5,000 ISIS unspoken limit.
Okay,
right?
Well, if you're over the 5,000 router limit, you have other problems.
But that's your whole bread and butter, right? Don't you specialize in hyperscale with a bajillion routers? I thought that was kind of your thing.
Yeah, but if you have a single fabric that's large, and I'm not saying, I'm saying that in a single flooding domain.
It shouldn't get.
Yeah, a single flooding domain shouldn't get that big, honestly. I mean,
when you talked about how big those route tables in the top rack switches were, I got a little confused. Like, why are they that big? And then I thought, I assume maybe that's just hyperscale world. And
yeah. Right. If you start thinking about if I have a 2500 router, 5-stage butterfly, and you start thinking about if I have 120,000 edge port, all of a sudden I can have 120,000 routes, right?
Gotcha.
Now, theoretically, I shouldn't in ISIS because what I should really carry in my underlay is my loopbacks, just so BGP can build the BGP sessions and I can build tunnel tails and heads. I should never, ever carry workload routes. My edge routes should not exist. Any of my workload ports should not exist in my underlay.
So you don't think we need Rift because your network should never get bigger than a 5,000 ISIS domain?
I wouldn't say we don't need it. I would say it fits a narrower slice.
Very small.
The number of environments that are going to operate at that scale is...
And Tony, by the way, will disagree with me. He'll say it's the opposite, and that's cool. That's fine.
Yeah, but who's right?
This is, always an ongoing discussion.
He wouldn't say that it's widely applicable in all. He would say that the protocol can work at subscale, but he wouldn't say that everyone's operating at that same scale and that the same scale requirements have proliferated broadly.
Yeah, he really targeted Rift at the 2,500, 3,000 router fabric is what he really targeted it at. If you're down at 100 routers or even up to about 1,000 routers, I think he would say, just use ISIS and be done with it. Like, this is just not. Yeah. The only other thing that was kind of cool about Rift is the ability to deploy EVPN, a kind of a lightweight cheating version of EVPN, and you don't even need BGP. There is a way to do that with Rift.
Blasphemy. We always need BGP.
It's cool.
How many people in the world, I mean, a ballpark, obviously not specific, but like know enough to express like a strong opinion about the protocol choices in the underlay? Because you have this discussion, right? But like if you go to even like very large networking players, like the number of people that can have that conversation and actually have an opinion. I mean, a lot of people can recap, here's how a thing works because they've read about it, but to know it well enough to say, and here's why I agree or disagree, and then I'm willing to debate on it. How many people can do that?
It's not very many. And I find that unfortunate. I find that a failure in our network engineering training world myself.
Do you think it gets better or worse over time?
I think it's gotten worse over time.
But like from here, like at some point, do you think it, like, do protocols become sexy again?
No, I don't think so. I don't think so. I think we are moving out of that realm. I think we're going to move. Now, see, the thing I like about running ISIS as an underlay is you actually don't have to know much other than just basic troubleshooting on it. It's literally a fire and forget protocol. Like, you turn it on, you tell it to run on everything except your workload ports, which is probably that, and running the net addresses, figuring out the net addresses are the two most complex things about running ISIS. And you just let it go. And it just does stuff. And all of a sudden you have IP reachability v6 and v4 for all your loopback addresses in all your routing tables on the whole fabric. It just works. Like, it's not very difficult to do. It's actually really simple. I'm building, I probably shouldn't talk about this very much, but I'm building a test topology I've been trying to play with. And the ISIS configuration in this little, I'll say more than 1,000 router test topology I'm trying to build is 8 lines of code and 1 line of configuration for every interface. I mean, seriously, there's nothing. My BGP configuration is 20, 30, 40 lines of configuration on every box. 80 lines of ISIS. It's literally like router ISIS, LabNet, or whatever you want to call it. You have to give it a name, a net address, and that's it. And then on each interface, you say, run ISIS. Okay, I'm done. And all of a sudden you have a routing table. Like, it's really pretty simple.
You know what's funny, Russ? I'm thinking of how much pride I used to have in my complex BGP configs with my prefix lists and my complicated route maps and, you know, all kinds of other stuff we're doing in BFD to make it faster. And we better put UDLD for one link. Like, it was so complicated, and I was so proud of it because look at what we've done. Like,
yeah. There's a lot of that network engineering. There's a lot of it. And
it's cultural, I think.
Yeah, it's
right?
cultural.
And I think it starts. So for me, and where I'm going with this is, my peers and I have never come across ISIS in any of the vendor trainings that we all consume to grow our careers. Mm-hmm. I don't understand that gap. I don't understand why I've spent a bajillion hours on EIGRP, BGP, and OSPF. And hearing what I'm hearing from you about ISIS, I don't know why our educational system is doing this disservice, if everything you've said is true, which I believe it to be.
I think it's people are scared of it to some degree. They've heard really, the net address is so long. Oh, it's so complex. It's actually a very simple protocol. In fact, the training is to the point that, like, who was it? Somebody and I wrote, I should remember all these things, right? A book on ISIS, which Mike Shand wrote the intro for, one of the people who invented it. And that is the book that most vendors buy when they want to train somebody on ISIS, on the protocol. And it's like 15 years old now. Nobody ever writes anything about it. It's completely.
I think it's the story you told about, like, the Cisco, the OSPF, breakpoint with 40 routers. Like, to me, that's an interesting symptom of the actual root cause. The number of people who have enough confidence in almost any of the really deep networking topics, it's declined over the years. And as it declines, then you end up with, anecdotes and stories and fears and whatever. They travel further and are more durable than truth. And then it will get worse because I think, we are in a bit of an attention span economy. I know Russ has talked about this a lot in other forums. If people are no longer willing to invest the time required to learn the thing, then they'll never develop the confidence or conviction to do anything different than what is done. If that's the case, right, are the operational concerns, do they outweigh the architectural benefits and even the operational benefits, by the way?
Yeah.
To me, that's an interesting question. And Andy, I mean, when you and I were talking earlier, I'll share the same analogy I shared with you earlier. Like, my wife and I, and I only say we because I don't want her to feel bad. It was her, though. But we bought a car, I don't know, 5 years ago or whatever it was. We got a Subaru Ascent, and I'm not a car guy. I don't know anything about cars. We got this car. It was nice to drive or whatever. Turns out it was the first year of this new, like, powertrain, like new transmission, new whatever. And then, does that matter? Like, I don't know much about cars. As long as, to me, that's plumbing, right? As long as it works, I just, I want the outcome of being in a car. Like I want the outcome of getting from point A to point B. So I didn't care about the details. And then you know what happened? The car broke down when my wife was driving with our 2 kids, toddlers at the time, and 3 dogs, and it broke down on the freeway, and I wasn't there. And then good luck getting a tow and then getting an Uber to pick you up on the freeway to pick up your 2 kids and your 3 dogs. That's impossible. So they were stranded for hours until they found a enterprise rental person who was willing to come pick you up in a car large enough to handle everything. But that was like a crazy ordeal, and trying to juggle like with the tow driver or whatever, that's crazy stressful. And so we're in the process now of evaluating a new car. And you want to know what questions I'm asking about? Like, tell me about the transmission. Like, it turns out the plumbing, it does matter.
Yep.
You just have to know that it matters. And then once you find out, like, once it breaks, like it can be catastrophic. And so for the people who don't peek under the hood, the people who don't take the time to understand, I think there's some value in abstracting out the detail. I'm not suggesting you have to go down, or that everyone in the company should go down to that level of detail. But I do think there's an argument to be made because, and then here's my thrilling conclusion for my analogy. The reason electric cars are interesting, partially, there's a power or a climate impact or whatever, but it just has fewer parts.
Yeah.
And if you don't care what's under the hood, then you miss some of the actual value that comes out of that.
Yeah.
ISIS to me is the equivalent of an electric engine, right? It has fewer parts.
It has fewer parts. That's exactly right. And there's a couple of things there. First of all, we don't realize that we don't seem to think about most of the major failures we've seen in large networks recently have not been protocol failures. They've been interaction failures.
Correct.
Interactions between protocols and something like DNS. DNS in particular is very problematic. And again, like BGP, we throw trash at DNS. Oh, it's DNS distributed data. We do anything we want to with that. Yeah, till it breaks. Then all of a sudden, it don't work no more. And now it's a big problem. And it takes a long time to reconverge. And the other thing I'll tell you about the decline, you talk about the decline of knowledge. Look, in my world, when I was coming up in the IETF, I've spent 20 years in the IETF, and I don't know if I'll be doing a lot more of it, and in the NOGs and at Cisco Live and everything, I don't believe, and you're going to laugh, Andy and Mike or whatever, but I am not the world's best expert at any of these protocols. I'm actually pretty stinky compared to a lot of people that I know. And it saddens me that that is not only true, but that now most of those people have retired and they are gone. Like, there are very few people. I hit a problem. Somebody emailed me the other day, like a week ago, and said, I have this problem. I'm implementing this RFC, and it's IS to IS, and it's encryption for IS to IS on the wire. And I don't, you were a co-author on the draft, and this is, I'm struggling with this little bit of it. So I read it, and I'm like, yeah, that wasn't my part of the draft. So, so I thought about it, and I asked somebody I know who's implemented it. And then I thought, the person I ask is semi-retired. Who am I ever going to ask once they're retired? Who do you go to next? And it's true for every protocol in the world. And BGP is the only one I can think of people who are under 25 or under 30 or under 40 who are as steeped in it as anything I would know or knowing more than I do.
Do you think we'll go back to big closed systems, like big black box things?
Oh, I hope not. I know that's probably where we're trending. That's where cloud trends to a large degree. But I really hope not, because I don't think it's good for the global internet. I don't think it's good for network engineering. I don't think it's good for companies personally. Like, I don't know how I hope not. I hope the open standards and open source vision can weather whatever this storm is we're seeing and come back to life or be serious. I don't know how to make it, but that's kind of my belief.
There's a lot of tribal knowledge that dies off as people retire and go off into the sunset. I think it's incumbent upon those of us left here. Mm-hmm. My little hope is that conversations like this might poke at, some curiosity to folks and have them dig in. That's what happens to me. So as we're wrapping here, I'm I'm looking up what network operating systems support ISIS that I can try to lab this with. Because what I'd like to do, Russ, because I have access to you, and why wouldn't I? I'd like to go lab this, fire it up because I've never done that, and see what happens. And maybe we could talk about it.
I have some labs in Container Lab that I can send you, some small labs that run ISIS. I actually don't have any OSPF labs in Container Lab. They're all ISIS and BGP. Again, not because I dislike OSPF, but I just find ISIS easier to configure.
But this past year, I've leaned into Linux and containerized NASes, and SR Linux being one of them. I see that it supports ISIS, and that'll probably be just, based on where I work and what my interests are right now, what I'll jump into.
So most of my labs are in FR routing for a very specific reason, because I give them out for training.
Yeah.
And I built a lot of them before I started working for Nokia. So, it's kind of a thing. I will probably rebuild some of them in SR Linux. The other thing is that's going to, I don't know, Mike might not like me saying this, but one thing about FR routing is that unlike almost any other protocol stack, I can shut off the protocols I don't care about. So it becomes very, very lean for a lab environment and building large topologies in a lab. It just is the way it works. Most of my labs, I only run OSPF, or I only run IS to IS and BGP. I don't run gRPC. I don't run Yang models. All of that is shut off. And not because I don't like them, not because, it's fine. RIP is there. EIGRP is, I just turn them off. And I turn off PIM. I turn off everything. And why? Because I can get the image down so small that I can push a lot of routers very quickly. It improves my lab speed, which has nothing to do with the quality of SRL versus FR routing versus blah, 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 blah. I don't really care. I'm just trying to build labs, right?
When you turn them off, how do you know they're not still chatting? And the reason I'm mentioning this so late in this episode, my friend Lexi Cooper discovered that most vendor NASes, when you turn off auto negotiation with her oscilloscope, she discovered it's still sending auto-neg link pulses. And
yes.
I thought, wow, you can turn off a protocol and it completely ignore you and keep doing its thing. So I'm being half facetious here.
It depends on the architecture of the NAS.
Yeah.
Most commercial network operating systems do not have the heritage of FR routing, which is a good thing. Honestly, it's not a bad thing. It's a good thing because most of them are built as complete systems. The protocols interact with each other. They have all sorts of APIs. FR routing is literally a bunch of routing daemons that were written by different people and thrown together under a single management plane just to make something, right? So that heritage has some good pieces. The good piece is I can actually go into the daemons file, turn off RIP. And if you go into the router and you say router RIP, it says, what are you talking about? I don't even know what you're talking about. Router RIP. What is RIP? Like those commands don't even exist.
So you're also an FR routing zealot, ISIS and FR routing.
No, not necessarily.
I'm teasing.
I like FR routing because I like it for labbing. It's lightweight, it's easy, it's open source. And I am a maintainer, so I do have to be a little.
Well, now that I can ping you on Teams, sir, and if I have any ISIS questions, if you're open to that, you may be
sure
hearing from me. I'm sure that's what you want.
I'm sure Mike's going to be PMing me tomorrow going, buddy, you better learn some SR Linux.
Russ, is there any closing thoughts you have around this? I would like to learn ISIS, and I'm going to lab it because that's what these conversations are about for me. A little bit of curiosity, learn something from somebody smart, and then go touch it and see what it's like. Do you have any educational material around ISIS? Have you written books or done classes on it?
Yeah, I have a book and I have a training course here. I have a couple of training courses I've done.
Can you plug the book? If you just look up ISIS Russ White, I guess it'll come up.
You can just look up ISIS.
Okay.
It's probably one of the very few books, but you know what? You might not be able to get it in physical format any longer.
I know a guy.
It's really out of print at this point, but you can get it in digital format, Safari books or whatever. Yeah. So no, not much else. Thanks for having me on. Probably need to do this more often. And Mike, I promise I'll learn SRL better and do some labs with it.
Thanks for coming on, guys. For all things Art of Network Engineering, you can check out our linktree/Art of NetEng. We have new merch up. We have a community called It's All About the Journey Discord server. Thousands of folks in there studying, learning, helping each other out. Hop in. If you don't have a community, check it out. It's a great place to be. As always, thanks so much for joining us, and we'll catch you next time on the Art of Network Engineering podcast. Hey folks, if you like what you heard today, please subscribe to our podcast in your favorite podcatcher. You can find us on socials at Art of NetEng, and you can visit linktree/Art of NetEng for links to all of our content, including the A1 merch store and our virtual community on Discord called It's All About the Journey. You can see our pretty faces on our YouTube channel named The Art of Network Engineering. That's youtube.com/Art of NetEng. Thanks for listening.